Assalamualaikum warahmatullahi wabarakatuh. Today we're going to present Mathematics Chapter 2 Geometry. Geometry is a fundamental branch of mathematics, deals with the study of shapes, size, dimension, and the properties of space. It explores the relationship between points, line, surface, and solid, forming the basis for understanding spatial reasoning. Rooted in ancient civilization, geometry has evolved from practical application like land measurement and architecture to abstract concepts used in a modern field such as physics, engineering, and computer science. Its principles are essential for analyzing patterns, solving real-world problems, and understanding the structure of the universe.
So, question 1. Ahmad draws a square with sides of length 6 cm. He then measures a diagonal as 8.2 cm. Use Pythagoras theorem to decide if Ahmad has drawn the square accurately. So, let's go to the solution. So, like the question asks to use the Pythagoras theorem. So the Pythagoras theorem formula is a square plus b square equals c square. So the a square, which is 6, plus b square, which is 6 too, equal c square. So we got 72 for c square. To get the c, we need to square root the 72 and we got the 8.49 centimeter. So the conclusion is, since Ahmad measured the diagonal as 8.2 cm, it is less than the aspect, which is 8.49 cm. Therefore, Ahmad has not drawn the square accurately. So, we go to the question 2. Which of these triangles contains a right angle? So, the solution, we also use the Pythagoras theorem, which is a square plus b square equal c square. So we go to the question A. So we know a square, which is 5 centimeter, plus b square, which is 12 centimeter, equals c square. So a square plus b square, we got 169 centimeter. To get the c, we need to square root the 169 centimeter and we got 13 centimeter. So b, 7 square plus 6 square equals c square. So we got 85 centimeter. To get the c, we need to square root the 85 and we got 9.5 centimeter. So the question C, 6 square plus 11 square, we got 157 centimeter. To get the C, we need to square root the 157 centimeter and we got 12.5 centimeter. So the conclusion, only triangle A contains right angle.
And then we proceed to question 3. An isosceles triangle is a triangle that has two equal sides. Also, the two angles opposite the two equal sides are equal. Determine and explain whether an isosceles triangle can contain a right angle. So, for the first picture, the image that got labeled with theta, which is theta 1, theta 2, and theta 3. So, based on the explanation on picture first, it shows that theta 1 plus theta 2 plus theta 3 is equal to 118 degree. So,
Okay, we go to the question 4. So this is the main question. Each shape in this question has an area of 10 centimeters square. No diagram is drawn to scale. So question A, calculate the height of the parallelogram, which is like the picture given. So the area given of the question is 10 centimeters square, and we need to know the area of the parallelogram, which is base multiply height. So we know the area given is 10 centimeter, and we know the base, which is 4 centimeter. So we need to search so 10 divided 4, and we got 2.5 centimeter for the height. Question B, calculate the length of the base of the triangle. So the solution, we need to know the formula of area of triangle, which is 1 over 2 multiply B multiply H. B, B is base and H is height. So 1 over 2 multiply base multiply height, which is height. The height is 2 centimeter equal 10 centimeter square, which is the first at the question given. So we got 1 multiply B, which is 10 centimeter. So B is 10 centimeter. The last question for question 4 is, what might be the values of H, A, and B in this trapezium? What else might be the value of H, A, and B? So, like the first one, the area given is 10 centimeters square. So we need to know the area of the trapezium, which is 1 over 2 multiply the total of two parallel sides multiply height. So the possibility here is 1 over 2 multiply the total of two parallel sides. We can put 3 centimeter plus 2 centimeter multiply 4, which is we got 10 centimeter square like the question given.
If you look at the image of theta 1, theta 1 is equal to 19. So it can be 19 degree plus theta 2 plus theta 3 equal to 118 degree. We proceed to picture number 2. Since one of the characteristics of an isosceles triangle is two angles that are equal, this means that theta 2 and theta 3 are the same. We can find the angle by dividing 19 degree by 2 to get theta 2 and 3. So you can see the calculation. So this is the calculation how to find theta 1 and theta 2. And for the last final answer, we got theta 2 and theta 3 is 45 since theta 2 and 3 are equal. The conclusion for 45 degree, 19 degree triangle is an isosceles triangle that contains a right angle.
Question number 5. The area that has been shaded in the diagram has an area of 21.8 cm square. Calculate the diameter of semicircular hole, giving your answer to nearest millimeter. As the picture shown, the length and height of the square is 9 cm and 6 cm. First, to find the diameter of semicircular hole, we need to find the total area. By the length given, 9 cm multiplied by height 6 cm, we got the total area 54 cm square. So to find the area of semicircle, total area minus area shaded, which is 54 cm square minus 21.8 cm square. We got the answer 32.2 cm square. Since we need to find the diameter of semicircle, we can use the formula of area of semicircle. We got the answer of diameter in cm, but we need to convert it to millimeter as the question asks.
We proceed to question number 6. The diagram shows a prism. The cross section of the prism consists of a rectangle and a semicircle. For question first, calculate the volume of the prism. First, we should know volume of rectangle, which is just use the formula height multiplied with multiply length. And then we got the volume of rectangular. And for the second one, we should find the volume of semicircle. Just use the formula. And after we got the both answer, just total volume rectangular plus volume semicircle. Then we got volume of prism. Next, for question B, calculate the total of surface area of the prism. First, we should find the surface area of rectangular, which is just use the formula. And after we find surface area of rectangular, we we calculate surface area of semicircle. Use formula as well. Formula surface area of semicircle, and then we should find the surface area of rectangular base. After that, surface area of curved surface equal to area of rectangular. So it's mean that we should find area of rectangular to find surface area of curved surface, which is on the top one. So when we got the area of rectangular, we total up all of them, all of the answer. We total them. So area of surface area, which is surface area of rectangular plus surface area of semicircle plus surface area of rectangular base and plus area of rectangular. Then after we total up, we got the answer in cm cubic.
Next, question number 7. The diagram shows a semicircle OABC of center O and radius 6 cm. BN is a perpendicular to OA, given that the length of arc AB is 6 cm and the length of ON equal to NA. Find the angle of AOB in radians. So, using this formula, we get the answer of 6 theta and convert theta to radians. Next, we need to find the area of the shaded region. So first, we need the area of cross section, and we got the answer of 49.64. And next, we need to find the perimeter of semicircle using the formula of area of perimeter of semicircle. We got the answer of 257 cm square. Then we find the area of two sides, which give us answer of 120 cm square. So to find the total surface area, cross section area plus curved side area plus two side of area, we got 426.64 cm square.
So, for question number 8, the diagram shows a sector Q or R of a circle with center O given that PS equal to 10 cm and QP equal to PO, OS, SR is all of that is equal to 6. For the question first, find the leg of the QR. Just use the formula S equal to R theta. And we got the answer for A. It's so simple. So we proceed to question B. We should find the area of shaded region. So how to find area of shaded region? Is area of sector minus area of triangle. So before that, we should find area of sector first. Use the formula and calculate it. Then we got the answer. After that, for the picture number 2, the area not shaded. To find area of triangle, we use formula Heron's. Heron's, which is Heron's formula to find area of triangle. Just calculate using the formula. Then we got the answer for our area of triangle. After we got the answer of area of triangle, finally, the answer of area sector, we minus area of triangle. And we got the answer of shaded region. So, after we got the answer for area of sector and area of triangle, just minus them, and we got the final answer, which is 125.626 cm. In conclusions, geometry is much more than the study of shapes and sizes. It is a profound mathematical framework that bridges the gap between theoretical concepts and practical applications. Its principles govern the design and structure of our physical world, influencing everything from the construction of buildings and the mapping of the earth to advancement in computer graphics, robotics, and space exploration. Through its diverse branches, Euclidean, non-Euclidean, analytic, and differential geometry, these disciplines provide tools to solve complex problems, model real-world phenomena, and even understand the fabric of the universe.